Well, hello and welcome YouTube. Mr. Robins back here with yet another brand new exciting video, all math-based course, and as always, it is an honor and a privilege to be serving here today, as it is every day, here in my virtual classroom. If you step on inside, coming off the heels of the Chapter 9 Are You Ready review comes the IM2 Chapter 9 practice test, if you will. So if you want to try it for yourself before watching this, please go and do so, and then score yourself with it. I don't know how many points we'd put these things out of, but give this a shot. Everything from 9.1 to 9.6, from the Big Ideas Math, Integrated Math 2 textbook on right triangles and trigonometry. Now, I do not plan on spending a long time teaching problems here. I just did an hour-and-a-half video on an Are You Ready section to see how prepared you are. Let's put this one to the test and see if you kind of get answers right. I can babble on and on as I'm writing stuff down or using the calculator, which is fine, but I'm probably not going to be doing the full teaching methods of before. But go ahead and download this thing below in the description section and find timestamps to each of these problems. I don't know if they go in order. I haven't tried the problems yet, so I don't know if they go in order of like 9.1 to 9.6 or anything like that. I can guarantee you're going to need the calculator at some point. Let's go ahead and get started on it. I think it's 4 pages long. The other one I did was 7 pages long, and I think this 4th page ends pretty fast. All right, practice test. Let's go. Solve for the missing side. That's out of 9.1. This is a Pythagorean theorem setup. X is your hypotenuse opposite the right angle. We're going to do an a squared plus b squared equals c squared setup here. That's 256, and this is 361. And this is, I'm trying to do this in my head, 617. I don't know if that has any square root of 617. I don't know if that has any perfect square factors. That would be an ordeal for me. I'm going to test some numbers. Here's what I do to test these out, by the way. This is teaching because I need to know if I have the answer. I'm going to divide them by only odd numbers, but only perfect square odd numbers. See if any of these work. 25 won't work, so what's 7 squared? 49. 8 squared, 9 squared. 617 divided by 9 squared, so 81. 10 squared, 11 squared. 13 squared. If any of these are integers, then it would work. I don't know. At some point, I got to give up. In fact, I think I'm past that halfway mark. I don't think anything here is going to work. I think I'm good. So just square root of 617 is going to be that final answer. We'll just leave it like that. Sorry about that. I wish I knew. It's probably even a prime number. So there's that. All right, number 2. A rope from the top of a mast on a sailboat is attached to a point 19 feet from the mast. If the rope is 28 feet long, how tall is the mast? Round to the nearest tenth of a foot. So 1 decimal place, have feet in your answer. It helps if you know what a mast is. I think that's the thing that holds the sails. So a rope from the top of a mast on a sailboat. So I'm not going to get too fancy in my drawings, but let's say this is the sailboat mast. And here's like the sailboat like bottom, if you will. Like that. So there's a right angle made. There's a rope. Let's see. The rope from the top of the mast on the sailboat is attached to a point 19 feet from the mast. So here's the rope. The 19 feet. Is the rope 19 feet? No. They said that the point the rope is attached to is 19 feet from the mast. The closest distance is the perpendicular one. So this is the 19 feet. Let me get rid of this. Normally I'd draw it more uniquely, but within a sailboat, we're doing this. If the rope is here's the rope, 28 feet long. How tall is the mast? There's your right triangle. Round your answer to the nearest tenth of a foot. We're going to do x squared plus 19 squared equals 28 squared. This time I don't need to bother with, we did 28 squared in the last one. I don't remember what it was. Oh, what did I just hit? I hit something wrong. 28 squared, 784. I forgot what I was saying. Oh, I don't need to worry about simplifying the radicals or anything like that. We're just going to be doing a rounding. So x is the square root of 423. Let's write that as an approximation. So it's approximately, what's the square root of 423? Oh, you can't see that. 20.56, so around 20.6 feet. That's the height of this mast here, 20.6 feet about. Okay, number 3, determine whether the triangle with the given side lengths is acute, right, obtuse, or not a triangle. So notice that 24 is the longest length, which to me kind of represents the C, if you will. Not only for a squared plus b squared, maybe equals c squared, but also to see if a plus b itself is even bigger than c. Is 12 plus 17 bigger than 24? Excuse me, let me do it this way. Is it bigger than 24? Well, that's 29, which is greater than 24. So that's our good first check. That's not the answer. That's our good first check in the problem. Now let's see how 12 squared plus 17 squared compares to 24 squared. If it's equal to, it's a right triangle. If it's greater than, if this is greater than, it's acute. If this is less than, it's obtuse. So 144 plus 289, and this is 576. Looks like it'll be less than. I'm going to get an actual number, though. 433? 433, I think. I just know it's less than. It's less than 576. If a squared plus b squared is less than c squared, you have an obtuse triangle. If it's equal, it's right. If it's greater than, it's acute. Number 4. Find the missing side lengths. Leave your answers as radicals in simplest form. It looks like they go in order because that was all 9.1. This is 9.2. We got a 30, 60, 90 triangle, which has a 1 to 2 to root 3 ratio relationship. That means that from the long leg to the short leg, I got to divide this by the square root of 3. Y is 21 over the square root of 3. If I rationalize that, that'll be 21 root 3 over 3. 21 over 3 is 7, so you get 7 root 3 as the answer for y. Right there, y is 7 root 3. X is double that of y. You see, this is a 1 to 2 relationship, so you got to double that. X is 7 root 3 times 2, which is 14 root 3. If you want me to slow down, you can literally slow me down on YouTube. You can create 3/4 speed, half speed. You can pause me. You can rewind me. If you want me to slow down an explanation, this is the practice test. At this point, it's check and see what you do know. Check and see if you're right or wrong. I taught these before, so I'm going relatively fast. On part B, A is going to be equal to 2 root 10 because this is a 45, 45, 90 triangle, which has a 1 to 1 to root 2 ratio relationship. Being isosceles, these are both 2 root 10. If this is, so is that. B is going to be root 2 times larger than either of these sides. So if I take 2 root 10 and multiply by root 2, I'll get 2 root 20. Now I don't want to finish there because root 20 has 4, square root of 4, as a factor, and root 4 is 2, excuse me. So we get 2 times root 5, which is 4 root 5. That was a long, exhaustive way for me to write that. Normally I would say it out loud and just write it down, but there, you got a little bit more out of me that time. But 4 root 5 is the final answer you should be writing when all said and done. That's part B. All right, let's go to number 5. Using right triangle similarity theorem, solve for x. Now, again, I don't want to overspeak on this one here, but I'll be dealing with proportions that we've been setting up in the past on these kinds of things, or I've been setting up in the past. X is something that represents 2 different parts of 2 different triangles. X is the long leg of this big triangle here. It's also the hypotenuse of this medium triangle. So that's important when it comes to me thinking about what I want to use here. I want to use the long leg of the big triangle, and therefore, and you heard medium triangle as well, so what's the long leg of the medium? 45. The long leg of the big over the long leg of the medium equals, X is also the hypotenuse of the medium. Oh, sorry. What did I say? Long leg of big, long leg of medium. Let's get the hypotenuse of the big. 45 plus 3, that's 48. Over the hypotenuse of the medium, that's x. Those are parts that correspond. When we cross multiply, we get x squared equals whatever 45 times 48 is. I'm not going to deal in such atrocities. I'm going to get to the square root part. This also means, guys, that x is the geometric mean. X is the geometric mean of 45 and 48, or x squared is 45 times 48. That's obviously what we got to right now. Maybe you learned that, maybe you didn't. Either way, we are there. If I take the square root of both sides here, I think it's going to help me best, though. Check this out. X is, root 45 is root 9 times root 5. That's 3 root 5. Root 48 is root 16 times root 3, or 4 root 3. 3 times 4 is 12. 12. And root 5 times root 3 is root 15. And root 15 cannot simplify any more than that will be done there. I'd say that's the fastest approach, because 45 times 48 is a number I don't know, and that biggest number is, I would not have known that 144 could factor out of that as the biggest value. That helps. Number 6, identify trig ratio, sine, cosine, and tangent of what's here. It would extremely help for sine of A to be opposite over hypotenuse, given that I knew what the opposite was. So how do you find BC? Well, you got your Pythagorean theorem to help you out. B squared plus 16 squared equals 20 squared. You also might know that this is a 3, 4, 5 Pythagorean triple, given that this is 4 times this amount, 4 times this amount, and 4 times 3 would be 12. So BC is 12. I'm going to save Pythagorean theorem work. You can do it as much as you want, but if you already tried it, that's what you're going to be getting. BC is 12. So go ahead and get that working. So there is that guy. However, having 3, 4, 5 probably would have been nicer for these because I got to reduce these fractions anyway. So the sine of A is opposite 12 over hypotenuse 20, which reduces to 3/5. Like I said, having the reduced values might be helpful to begin with anyway. Cosine of A, oh, I'm sorry. I didn't notice that they were being specific about things. Tangent of A, I thought they just wanted sine, cosine, and tangent of all of them. Tangent of A is opposite over adjacent, 12 over 16, which is 3/4. And the cosine of B, guess what? Cosine of B is going to be the same as the sine of A. Because, oh, never mind. I take it back. I thought it was C. I thought B was this guy. All right, cosine of B. Here's the thing. I wouldn't have taught this to my students at this time. I'm not saying that it can't, but let's go with the calculator on it. The answer is 0. The answer is 0. You shouldn't know why. You wouldn't know what's adjacent to B here in the hypotenuse. I'm not going to talk much about that. I'm going to say go to the calculator on it in this case because B is a 90-degree angle and cosine of 90 is 0. Okay. All right. So I'll tell you that's going to be more for IM3. I thought this was going to say cosine of A or cosine of C or something like that. It wasn't. Sorry about that, but that one's 0. Okay. All right. Number 7. Solve for the missing side. X. 31 degrees has the opposite known. The hypotenuse needs to be known. Let's use sine for that. The sine of 31 is opposite over hypotenuse. If you've seen previous videos that I've done, multiplying both sides by x and dividing both sides by sine of 31 gets you to your answer. They switch places. X is 11 over the sine of 31. 11 over sine of 31, which is about, I'm going to round to the nearest tenth, 21.35, so 21.4. It's more than 11. I'm going to trust the answer for what it is. Part B, x is, in relation to the 70, it's opposite that, and the 6 is the adjacent leg, so let's use tangent for that. TOA, SOHCAHTOA, tangent of 70 degrees equals opposite over adjacent. In this case here, to solve for x, I'm going to multiply both sides by 6. So x is 6 times the tangent of 70 degrees, which rounds to, a number. 6 times tangent of 70 is about 16.48 or 16.5. And that's that result there. That's A and B. Probably the only questions of that type to go on this practice test. Find the measure of the angle indicated, round to the nearest tenth. There are 3 of them. Now, we have options on what to do. Oh, I take it back. This is not a right triangle. Okay, so for this first one here, I didn't know what to expect here. So for the first one here with the x, we have kind of some options on what we still have options. But what we can do here is we can make a right triangle out of this and kind of work off that, see if that's going to help out. I don't know if this was intended to be a problem on here. I'm not going to pause the thing, but I'm going to think about what I should say. All right. I'm just going to go straight into it. All right. If you don't know how to do this problem, that's totally okay. Given that this is making sure this isn't a right triangle, right? 21 squared plus 25 squared. That's not 26 squared, right? Square root of that answer. No, it's not 26 squared. Okay. This is not a right triangle. Okay. I don't know what was intended for this problem when it was built, but I'm going to go ahead and tell you. You have to use what's called the law of cosines. If I want to find the cosine of this x degrees, it's okay that you don't know this. This will be, do I even remember it? I think 21 squared plus 26 squared minus, minus 25 squared. You got to use these two sides that are adjacent or that make the angle and then subtract the one that's opposite it, and all divided by 2 2 times 21 times 26, I think. The 2 times those two. I should know this. I know the other one where I'd say, let me write this. 25 squared is a squared plus b squared minus 2. 21 times 26 times cosine of x. So, yeah, I think that's it. Okay, so there's my setup. 21, I did not expect this thing here. This is an IM3 thing. 20, or pre-calc, so it's minus 25 squared. So this is 492 on top. Cosine of x is 492 when you combine all those. And 2 times 21, that's 42, times 26 is 1092. I'm not going to bother reducing that because my goal ultimately is just to 1092. My goal ultimately is to just take the inverse cosine. So x is the inverse cosine of 492 over 1092. This is not an IM2 based problem, so it's okay if you have no idea how to do this. Inverse cosine of that is 63.22, so around 63.2 degrees. Interesting problem provided. Okay. All right. Full disclosure, I didn't make the worksheet. All right, part B. X degrees right here, and the 21 and 25. All right, now it's in a right triangle. So this one we have the adjacent and the hypotenuse. Cosine of this x degrees is adjacent over hypotenuse. We do solve these. I didn't really mention this, but we take the inverse cosine of both sides here to get x by itself. So the inverse cosine of 21 over 25, this is right up your alley for IM2. Let me show you in the calculator. Inverse cosine of 21 over 25 is 32.85, so 32.9. It's around 32.9 degrees. And there's that answer. And in this last one here, I want to use sine, opposite, and hypotenuse. The sine of x is 17 over 19. So the x degrees, we got to take the inverse sine of both sides. Now, when I say taking the inverse sine of both sides, you probably notice that the sine goes away. It's gone. Where did it go? The inverse sine of the sine of x is just x. It cancels out. It cancels out, and there's that. So the inverse sine of 17 over 19 is 63.47, so around 63.5 degrees. There we go. All right, number 9. Find each angle measured to the nearest degree. We got cosine of A is that, and tangent of B is that. I mean, it's going to be the same thing as what you saw before. This is a ratio, so we just got to take the inverse cosine of both sides so we can get the measure of angle A. So now we're going to get the inverse cosine of this, 0.8660. I'm used to seeing that number. I forget, is that root 3 over 2? This should be close to 30 degrees. Wait. This should be close to 30 degrees, I believe. So inverse cosine, I'm used to seeing that decimal. Inverse cosine of 0.8660 or 0.866, 30, yeah, so 30 degrees for that one. And then the inverse tangent, I don't know this other, I just lost my page, or where did I go? Inverse tangent of this guy, I'm not familiar with that decimal. So measure of angle B, we take the inverse tangent of that guy, 8098, which is about, I must not be a very special one, 0.8098 is 39 degrees when rounded. It's nice. It's 39.00055, etc. Okay, number 10. The Tower of Terror ride in Disney World, Florida is 199 feet tall. I don't know if that's fact or fiction, but let's go with it. If Josh is standing 132 feet from the base of the ride, what is the angle of elevation from the point where Josh is standing to the top of the tower? So here I have Josh. Josh is on the ground. Josh lost his body. Josh is on the ground. There we go. There's a ride. Tower of Terror. Whee! There it is. Oh, it's a tower. So, okay. Honestly, I'm sorry, I've not gone to Disney World. I don't know what it looks like, but there's a tower. Tower of Terror. It's 199 feet tall. So 199 feet here. It's a right angle. that's made there with the ground, because it's vertically up. And then if Josh is standing 132 feet from the base of the ride, so he is standing here 132 feet away, what is the angle of elevation from the point where Josh is standing to the top of the tower? I want to know what this angle is, that theta. So here's the drawing, and in relation to theta, we have the opposite and the adjacent. I want to use tangent for this problem. The tangent of theta is 199 over 132. So theta is the inverse tangent of 199 over 132. And I don't know how many degrees they want to round to. Probably I'll do the nearest tenth. So inverse tangent of 199 over, I know it's more than 45. 56.44, so 56.4 degrees. There's Josh, there's Tower of Terror. All right, number 11. Solve in terms of others. Find the cosine of theta if sine of theta equals root 17 over 17. There are two ways to do it. One that I less prefer, and that's this one. There's a Pythagorean identity that the sine squared of an angle plus the cosine squared of that same angle equals 1. These are both that same angle, theta. We know that the sine of theta is root 17 over 17. So the sine squared of that angle is where you square these things. So root 17 squared is 17. 17 squared is 289, and that reduces to 1/17. So sine squared of theta is 1/17 plus, here's cosine squared of theta. We still have to solve for cosine of theta. So I'm going to subtract 1/17 from both sides. And 1 minus 1/17 is 16/17. Otherwise, if it's a little trickier, you got to get a common denominator. But 1 is, 17/17. And then the cosine of theta, you take the square root of both sides to get the cosine of theta, right? So I can do square root of this side, square root of that side. So the cosine of theta is 4 over root 17, which rationalizes to 4 root 17 all over 17. And that's one way to get the answer. Not my preferred for these kinds of problems, especially with the fraction involved. So what I'm going to do instead on this one is this. I'm going to draw a right triangle, place theta in there, and let's talk about how sine is root 17 over 17 like that. To find the cosine of this theta, I need adjacent over hypotenuse, which means I need this side length here. Let's just call it x. So x squared plus root 17 squared equals 17 squared. That's my Pythagorean theorem setup. So that's x squared plus 17 equals 289. Or x squared equals, subtract that, you get 272. Now, this is not the cleanest of values. This actually lends to this version maybe being a little cleaner if you're comfortable with common denominators. But x squared is that. And take the square root of both sides here. Now we got to figure that thing out. That's 4, let's 272 over 4. 272 divided by 4. 68. Ooh, there can be something bigger. Let's do 272 divided by 16. Perfect, 17. So this is root, I'm going to write this, root 16 times root 17. Oh, I should have known that, which is 4 root 17. Okay, so x is 4 root 17, and then I can take the cosine of this thing. Cosine of theta is adjacent, 4 root 17, over hypotenuse 17, and there's the answer. So we got that above, we got that below. Just that simplifying radical was kind of bigger than we normally deal with. You know what we could have also done was, this root 17 over 17 to begin with, and I kind of did it in a way here with the sine squared part, but this is a rationalized denominator. This was after multiplying top and bottom by root 17. That means this is the same as 1 over root 17, which means I could have done a right triangle with that theta where this is 1, this was root 17. That would have been a lot easier to deal with. I'd have to rationalize later for cosine. Still would have worked. All right, let's keep moving forward. And I think this is the last set of problems, the last two. Find all missing sides and angle measures in each triangle. This is this 9.6 material, so solve for this whole thing. We have a 31 degree angle and this 14 side length here. Did we do this problem in the review? I can't remember. Let's find this guy and this guy here. Let's start with sine. We'll do the sine of 31 degrees equals 14 over that length AB. AB switches places with sine of 31. AB is 14 over sine of 31. It should be more than 14. It should be close to, it should be close to 28. Yeah, I think we did do this problem in another review. 14 over sine of 31 is 27.2 about. But just because you may have seen it, here's the thing, you might not have seen that video. But even if you did, you still got to know how to do it. Let's find AC, the length of AC. Let's take the tangent of 31 degrees, which is opposite over adjacent. Notice how I'm using the exact values that I have, not the rounded 27.2. Switch places with that guy. It's 14 over tangent of 31. I don't remember what this value was, unfortunately. 14 over the tangent of 31. Now I'm getting 23.3 about. 23.3 units there. And then lastly, this angle B is 90 minus 31, because these both should add to 90, as all of them add to 180. And that's going to be 59 degrees there. And I could have used the 59 to get some of the other values with 14, but I'm good with where I was. The last problem here, let me move myself, but the last problem here, part B, I don't remember this problem. I might have used it, but I don't know. Look, let's get this 20 degrees right now. Let's get it out of the way. Notice I never used cosine on these two problems. Let's use cosine twice. Why not? I want to find the length of AC. That's adjacent over hypotenuse to this guy. I can say the cosine of 70 equals adjacent over hypotenuse. So AC, whoops, not A. So AC is 5 times the cosine of 70, which is about, whoa, 1.7. I was expecting something bigger for some reason. About 1.7. And then let's find BC by using cosine as well. To do that, I need adjacent to that angle, 20. So let's do the same thing. Cosine of 20 equals BC over 5. And now BC is 5 times the cosine of 20. This will be bigger than that other one. And 5 times the cosine of 20 is 4.69, around 4.7. There we go, like that. And that solves the triangle. Remember, to solve the triangle, we need all sets of sides. Now, none of these problems ask me to use Pythagorean theorem on them, in that if sometimes you're given two sides, and then you got to find the third using Pythagorean theorem, you might say, could have I used Pythagorean theorem with this and this to get that? Yeah, but I don't want to use a rounded value, so you'd have to use the exact one if so. All right, guys, I was under a half hour. That'll do it for this one. This is Mr. Robinson. Thank you so much for watching on this practice test. Hopefully things all went pretty well, except for that one problem. Let me find it again and kind of just give an asterisk and say, be careful. It's 8a. That uses something called the law of cosines. That's not something you should have been expected to be able to do. But thank you guys. Oh, and there was one more, the cosine of the 90-degree angle. That was on number 6, cosine of B. Be careful on those two. Thank you guys so much. That'll do it for this one. Take care. I will see you in the next one. Peace out.